Hello everyone, welcome to my channel. In this video I'll show you the new features that I have added to the Falloff tracer node. So now it has two modes, which is tracer and the vector. Tracer is the previous one, but now it outputs also the curls of the input vectors, and the new one is the vector. So it only outputs the vectors and the curls based on the input Falloff. So if you use Noise Falloff, then it's going to output the vectors based on the curl of this noise, and also gives you the curls of that noise for the input vectors. So you can utilize these different ways, like you can use these curls for the particle system to create this curl noise based motion of these particles. You can also use curl 3D, and then you have curl gradient as well. Okay, and you can convert these vectors into a point cloud with the geometry nodes that you can render in the cycles, or you can convert these vectors into a tracer. Like in this case we have this spline tracer with the animation node spline, mesh or stroke. You can also convert these vectors into the splines or mesh lines with the geometry nodes, which is much faster as compared to the animation nodes. So that I'll explain in this video one by one. So let's get started. Okay, now let's add the Falloff tracer node. So this mode I have already discussed in my previous tutorials. Let's go to the new mode, which is vector. So let's input the vectors. So distribute node. So change this to a circle. So we have this. Let's also view this. Okay, basically we have on these circle points 50. Okay, now if we view this, we have these output vectors, but they are same because we haven't plugged any Falloff. So let's add the Noise Falloff. So we have this. Maybe change this to 2, and this maybe to 2.5. Let's fire maybe 1.5. Yeah, okay. So now if we increase the number, so we have these curl noise based vectors, and now we also have these curls. Let me change this amount to 1 and this to 1 as well. So what I want to show is that add the viewer node here and also the curl. So we have one input vector, we get that initial input vector and the curl of that vector based on this Falloff, which is Noise Falloff. Now if we go to the second iteration, then it's going to give the next vector, which is basically the addition of input initial vector, this one, and it is curl. We get this new vector, and based on the new vector location we get the curl, and so on for the other iterations. So this is how it works, so which is really important to understand when you use this for the particle system. So let's back to this vector. So let's change this to 50, change this this value to 250. So we have these vectors. Now we want to convert these vectors into a spline with the geometry nodes. So let's first convert these into a mesh vertices. So combine mesh node, then we need a mesh object output node. So hide this, we have this. And now let's go to the geometry nodes, select this and click this. We have this new geometry node modifier, but I'll show you how to convert these points or vectors into the mesh lines or curve lines. So for that I have created this group node, which is vector to curves. Just plug this here Then you have to input this value, which is iterations and the amount of vectors. Our amount of vector is 50, so let's type here 50, and number of iteration is 250. So you have these lines. So let's output these inputs, so we can directly link these inputs from the animation nodes. So let's add the object attribute output node. So plug this into this, and so let's right click on this and copy data path, paste here. Now we have this. So this was the number of iterations. So let's input the integer, type here 250 and plug this into the iterations and this. So we have this. Now we have linked the number of iterations. Then we can also link input vectors. So copy data path, paste here, and then we need is the get list node. Select this and plug this into this. So let's make a frame for this. So now you can easily control the number of input vectors from the animation nodes. So let's add maybe 250. So in geometry nodes, you can easily trim these splines and convert them into a mesh as well. So it is much faster. And then you can convert it into as mesh as well, curve to mesh, and then as circle 3 and plug this to profile. Change this radius to 0.5, maybe 0.35, and then you can add different materials to this. You can also add different attribute to these splines to get different look for your graphics. This is how you can going to convert these vectors into this spline with the geometry nodes. Now I'll show you how to use these calls for the particle system. I have added this animation nodes based particle system. So these are the group nodes that I have created. So you can download from my Patreon page. So let's add an input particles group nodes. So select this emitter here. So we have this, and this node basically gives you all the outputs, location, velocity, size, and other things of the particles. And here is option to update the cache. So when this time range completed, it's going to update the cache, which is important when you using this animation node based particle system. So let's add the particle output node, plug this, and you can modify different things for the particles. In this case, I'm going to change the velocity of the particle based on the curl noise. So let's add the Falloff tracer node, change this to vector, and we need only one iteration because we are going to use only the curl of the input vectors. Then we need the Noise Falloff, plug this to this, and now if we view this, we can see that particles are following on this noise. Let's increase the frequency, maybe 2 octave, and here you can also increase the strength of this curl force, maybe 1.5. And another thing is, especially in curl 3D, you have vector on the mesh, and then you have a new option which is the relative curl. So this is really important, move these particles onto the mesh surface based on this noise or the call noise. So let's add a cube and let's bevel this, something like this. So let's input that cube here, select this and plug this into the Falloff tracer node. So, and now we have the curl based on this cube, but we can see that the particles are not sticking to the surface. So for that you have to enable this relative curl option. It's going to create the relative curl based on the particle location from this mesh surface. Now these particles are going to follow the mesh surface. See? And now if you change this to gradient 3D, and it's going to also work for this gradient as well. Means if I disable this, see all the particles are moving according to the gradient of this noise based on this mesh surface. But if we enable this, it's going to move these particles based on that gradient but onto the mesh surface. Okay, and another thing is, so let's delete this cube, and if you change back to this curl 2D and we have this, now let's delete this and add the distribute grid here. Let's change this to circle and let's add the 3D viewer node so that we can see the circle point. Then I'm going to use this point distance of Falloff. So let's plug this here, change this to 5. Maybe I'm going to increase this, change the Falloff 2.5. See, we have this kind of motion. We can increase the number of points or decrease it. There are many ways to use these curls for the particle system, especially based on the Falloff. Means even you can combine with the noise to get different pattern. So this is it about this new updates about the Falloff tracer node. You can download the finished project files as well as the group node from my Patreon page. So if you like this work, then please do support me and subscribe to my channel for more updates. Until next time, happy noding, bye.